Temperature sensors. A simple series circuit with two resistors. The first resistor is inside the PCM and is fixed. My dog knows. The sensor is a temperature sensitive variable resistor called a thermistor. When you hear the term thermistor, meaning a change in voltage with temperature, it's temperature based. The ECM monitors the changing voltage on the center wire output to the ECM/PCM. Here's a thermistor. This section here sits inside the coolant. And this wax element here changes resistance based off that temperature. And on this side, this is where the actual electrical plug is plugged into it. And you got the PTC, positive temperature coefficient thermistor. I don't think they use these anymore, but the temperature increases, resistance increases. They're not going to talk about that one in the test, but they will be talking about the negative temperature coefficient thermistor. As the temperature increases, my resistance decreases along with the voltage. That's the part you understand. This is based off resistance. A cold car has high resistance, high voltage drop. As it starts to heat up, the temperature goes up, my resistance comes down, and the voltage drop comes down. When I say voltage drop, that's the voltage input to the PCM. That voltage input to the PCM determines to the PCM the car is either hot or cold. As you can see here, let's start off in a cold car. Let's say 68 degrees, right? My resistance is going to be somewhere about 11,000, 13,000 ohms. As the temperature starts to heat up, let's say it goes all the way up to 212. Look at the resistance, 640 to 720. Let's start back at 68 degrees again. Let's go cold. As it gets colder, let's say 32 degrees, my resistance went up. My resistance also went up. From like 29,000 to 35,000. Here's a thermistor circuit. This fixed resistor. This is the PCM/R ECM. We call it PCM now. This is the thermistor inside the intake or radiator, usually the intake or block. I'm sorry, it's located either in the intake, the manifold, the block. They have sometimes they have it inside the radiator also in older cars. But usually an intake manifold or the block. So anyway, here's the PCM. 5 volt power. Most every sensor receives 5 volts. A fixed resistor meter does not change. This signal wire is internal voltmeter. It's called a comparator. It's going to watch the voltage change on this second resistor off the temperature. And we got the return wire back to ground. Now the key thing you need to remember here, any resistance change in this circuit affects this signal line, and to the PCM it's a temperature change. As you look at this, we started off before about 68 degrees before. Let's say the car is right here, about 68 degrees Fahrenheit. On a cold car, if I back probe that sensor, it'll be about 3 volts. As it starts to heat up, let's go to 212. Now back probe that same sensor, I'll watch the voltage change on it, about 0.4. 0.4 of a volt. And you can see my resistance will change also. But usually when we check resistance, when we're checking a thermistor, we're usually checking the voltage change. That's the easiest way to do it, in my opinion. And you can see the swing here also. All right. When you got the temperature, you got, what's this, 68 degrees Fahrenheit. You come across here, boom, a little over 3 volts. Remember, it's like this. If we go to 212, as soon as we hit the line, we come back down. You can see it's about half a volt, 4/10 of a volt. And here's the problems. They're going to give you some problems on the test you have to understand. One is open reference voltage, signal wire, signal ground off the thermistor. In other words, this resistor has an open in this wire, or an open inside the sensor, or an open on the ground wire, or open inside the PCM on the ground. In that case, the PCM is going to see 5 volts. And that 5 volts to the PCM is an extremely cold car, very high resistance. Let's see if I can find that chart again. Where's the one with the 5 volts? The chart don't go that far. Right here, it don't show the voltage, but anytime it sees 5 volts, that's a negative 40 degrees automatically. If it's shorted out, it's 248 degrees, extremely hot car. That's default values. A shorted sensor, a shorted circuit, 248, very hot, default number. A negative 40, very cold, default number. That's an open circuit, this is a shorted circuit. So open the reference signal wire, or signal ground off the thermistor, the PCM is going to see a high voltage. Next one. Signal voltage low. Shorten the thermistor, short the ground, or in the reference signal wire. So, it says signal voltage low. I don't think I mentioned this last time, but this 5 volt power supply wire on this line is also the signal wire too, for a 2-wire sensor. A 2-wire sensor, this 5 volt feed is also the signal wire. So what this is saying here, that signal wire is shorted. So what it could be is this wire, 5 volts touching ground. I'm going to see a low voltage on this line here. These 2 wires touching together, this one and this one touching together, signal wire low also. Okay, now remember we said that's a short, low resistance. Look at that, 248 degrees, default number. What else? Let's see, what else is it saying here? Short, wire short. Oh, short thermistor. Internally, the thermistor itself internally is shorted. Low voltage here. This 5 volts short to ground. Low voltage here. These 2 wires touching each other. Power wire, ground wire touching. Low voltage here. And to the PCM, that's an extremely hot car. What's the next one? Achieved resistance reading, the reading that's wrong. Let's say that what this basically means. I'm back probing a sensor with my voltmeter on a hot car. Let's say it's 212 degrees. That's the wrong one. Let's say it's 212 degrees. I'm expecting to see a voltage of 0.4. Instead of seeing 0.4 on a hot car at 212 degrees, I see 3.52. Let me say that again. On that signal wire at 212 degrees, I expect to see 0.4 volts. Instead of seeing 0.4, I see 3.5 volts. That's the wrong reading. What can cause that? Extra resistance. Remember, the higher the resistance, the higher the voltage drop. So that means I can have resistance on this ground terminal, this ground wire, this ground connection here, the connection going to the thermistor. Any resistance, any unwanted resistance can cause that voltage to be wrong, skewed. So if I have a reading that's erratic or way off, like I just mentioned, I got unwanted resistance somewhere in this circuit. It could be even here. It could be the connectors here. It could be this background here. Any unwanted resistance, my voltage go higher than normal. Resistance on the ground terminal, I just said that, right? The piece I'm going to pick this up as a colder car because remember it's on a voltage drop from here on this line to ground. So it don't know if I have bad resistance here. It just thinks this resistance is here. So the resistance here and bad resistance here increases the total resistance. So it thinks a colder car than normal. What's for the action? On a properly operating vehicle, I'm going to have a voltage drop here on this thermistor. Say 212 degrees, 0.4 volts. On this ground wire, I should see near zero here, indicating a clean ground. If I see anything higher than that, anything higher than 0.1, that's resistance on the ground wire, the PC I'm going to think the car is cold. I think that should cover it. Well, if you had any other questions, let me know. Let's go to the next one. Peace.